So next topic is free fall. Free fall is nothing but whenever you take an example, a stone, if you have thrown the stone from certain height, means that stone will attract by the earth gravitation. Due to earth gravitation, that object, that is that stone, will fall from the certain height. So this which is the object with this body, or the body which is falling towards the earth due to gravitation, that is the free fall of the object. That means, for example, if the object is falling, means then the velocity, what happens to velocity? For example, the ball is moving from certain height. This is the height of that. It is moving towards the ground. It is the ground here. The object or the body is falling towards the ground, means what happens to its velocity? Whether the velocity is changes. If we are seeing velocity is changing, means in the velocity two terms should be needed to change. One, magnitude should be changed. Another one is direction should be changed. Either of them should be changed, isn't it? If the velocity of that object is changing, means either its magnitude, that means velocity while it is falling down, it should increase, or either it should decrease. Then or else the direction, if you are falling from here, either it should move here or in the some other direction. But whenever free fall, if you have considered, in that cases, the velocity will not change in terms of direction, is it? If you have thrown a stone, means in the same direction, in which direction you are throwing, in the same direction, the object will fall down. Here we are not considering any other forces, okay, air resistance, all those forces we are neglecting here. Even the frictional force we are neglecting here. Only we are considering the gravitational force. So here, in which direction we are applying the force, on the same direction the object will fall down. So velocity in the direction wise, it won't change. But let me abbreviate about the magnitude. What happens to the magnitude of the object? That is, magnitude is nothing but value. Whether the velocity when it is in this position or in this position when it falling down, whether the magnitude will be same? No, isn't it? Whenever we are going towards the ground, that is, when it is near to the ground, its velocity will be increases. That means there will be a continuous change in velocity whenever we have considered the free fall of the object. So if the velocity is changing, means I can say the term as acceleration. Change in velocity in terms of time. For example, object I have thrown from this point to this point. Okay, so in this position I have considered the time. So for example, 1 second, how much the acceleration? Next, for this position, for 2 seconds, next 2 seconds, what is the velocity of that object? Isn't it? If you go on doing that, here for the time being, how much is the velocity? That velocity is when it comes to downwards, it is going on increasing. So that means the term acceleration comes to here. This acceleration, this is very important, this acceleration due to attraction or due to gravitation is called acceleration due to gravity. This is the separate one what acceleration we have discussed. We have discussed the acceleration when it is other object, when it is straight line or in a circular path, we have considered the acceleration. Where we have not considered about the gravitation. That term we are saying A. By the A we are denoting that acceleration, but this acceleration which is due to gravity we are defining in terms of small letter g. Small letter g is nothing but it is acceleration due to gravity. Okay, so this is the separate concept in accordance with the acceleration. Acceleration is separate and acceleration due to gravity is also separate. Now the question has been came to many of the scientists that when Aristotle, name of the scientist, it's also like story. So what he has done means he took a stone or the metal coin in one hand, and in another hand he has taken the feather. So he's stand in one height of the building or in a stone. When he stand in a certain height, when he throw that, he came to the conclude that heavier objects will move with a slower velocity. That means heavier objects will come at the last. that is lighter object, feather will move with a greater velocity compared to the heavier object. He has concluded that wrong statement, that lower object, that is lighter objects, will be moving with greater velocity or will moves to the ground in that is in a greater velocity, or compared to that metal coin which is the heavier objects will have the less velocity. This was the prediction by the Aristotle. So many years we have with the same prediction about the lighter objects as well as heavier objects. But next comes to the Galileo. So what he has said about this one means, he went to the Pisa Tower, leaning tower of Pisa. In that he stood there and he took two independent mass stone he has taken. Both the stones he has taken, one will be having heavier mass and another one be having the lighter mass. So what he has done, he has thrown the two stones with the same time. In the same time he threw that. What he observed is their velocity was not changing. What the Aristotle said is lighter objects will have the greater velocity and the metal coin, that is the heavier objects, will have the less velocity. But Galileo, with the same object, he has taken a different mass of that object. He has taken that stones. Whenever he throw that, the velocity of that stone, that is the, I can say, change in velocity means gravitation, acceleration due to gravity of that force, that objects remains same. So what he has stated about this means it is independent of masses. Okay, free fall of the object, it does not depend upon the masses. Okay, it is independent of the masses, he has concluded. Okay, based on this, there is one formula to derive the acceleration due to gravity. Since you know from Newton's second law, F is equals to ma, here acceleration is, it is due to gravity. I will be changing F is equals to m into g. Secondly, we have done a universal law of gravitation. F is equals to gmm divided by d square. So F is, I'll substitute this value, m into g equals to gmm divided by d square. So m and m cancel. So g is equals to gm divided by d square. So this is the formula for the acceleration due to gravity. If the problem is find the acceleration due to gravity of any of the object given with the mass and the distance of separation, means you have to use this formula to find out the acceleration due to gravity. Okay, so this is about free fall and on problem based on the gravitation chapter. So based on this, I have given some of the questions on the worksheet. Try to solve it, and further certain topics we will discuss in an interaction section. Thank you, students.